Today our lesson is about work. This term work is not the new word or new term for you, but this word in physics context and in social life, how we are using this word. Let us see together. Work is the term which we are using in our daily life. So it is not a new word, but in physics it is a specific word. It is very specific in physics. For example, when I am carrying this marker even for 2 weeks, by being there, I am not doing any work. In physics, said to be work is done on this marker. This marker should be moved from its initial position to the other position. So when I move this marker from here to here, its first position is here, its next position is here now. So I am doing work on this marker. I displaced this marker from its initial position to the new position. So now in physics context, I am doing work on this marker. So work can be defined as energy transferred. Simply, work is energy transferred. So when I apply force in any object, for example, if I apply force on this box, I displaced it and this new position is here. Now, really, I did work on this object. This is distance I displaced. The distance that this box is traveled is called d. So, in work and energy relation, both have the same unit. Their unit is joule, and both are scalar. Both energy and work are scalar. So depending on this, we can now define the mechanical work. Mechanical work can be defined as is energy transfer from a force through distance. Depending on this mechanical work definition, we can have work done equation. Our work done equation is work is equal to force times distance. Work is energy transferred. Energy transferred. The SI unit of work is joule or capital G. Capital J, and if this SI unit is Newton. For distance, we have meter. SI unit of distance is meter. In this occasion, further we should have to understand force and distance relation. In force and distance relation, always distance should be in the direction of force. Whether it is in opposite or in the same, always distance should be in the direction of force. So, to further understand about work or work done, let us see some examples. Let us have this box, and this box is displaced to this position by someone. There is applied force for Newton, let us say, and from here to here, this is distance, it is 20 meter. Now you ask to find work done. What is work done? From work done equation, we have work is equal with force times distance. So from here, force we have 4 Newton, distance we have 20 meter. Simply, when we multiply 4 with 20, we have 80 Newton meter, or this is a unit 80 joule. Now, the work done on box is 80 joule, or energy that transferred to this box is 80 joule. Let us continue the other example. Let us example 2. Let us also consider now a box. This box slide to this position from here to there. Okay. 5 meter, and the weight 2 Newton. We ask to find work done. So how we can find work done on this box? To find the work done on this box, simply we should have to understand about the force and displacement relation. Under force and the displacement relation, we have said force and the displacement should have the same direction. They are in the same direction. So here, 2 Newton is acting downward, so it is vertically acting on this box. But the distance that this box is traveled is in horizontal, so it is not in the same direction. Whether it is opposite or in the same direction, the distance should be in the direction of force. Now, also this one is given, the vertical displacement, okay, is 3 meters. If this is not given, angle should be given. Then we can have by trigonometric relation, we can have the value of vertical distance. So now easily we can find work done, force times distance. Now 2 Newton times 3 meter. So we can have 6 joule. This is the answer. Is the answer for work done on this box. So by this means we can find from the first example, this example is in some extent it is different. The difference is here the box slided in angle to the force direction. So we should have to find the distance that is in the same direction with force. Now probably it is given for us 3 meter. It is vertical, so this one is also vertical. We can multiply them. We can have work done on this box simply in this manner. Let us see the third example, which is in some extent complex than two examples that we have seen before. The third example, someone is pushing a shopping cart. This shopping cart, let us draw a shopping cart, but I am not good in drawing, but let us try. Let us try. Someone is pushing his cart. He applied force by angle 30 degree, and this cart is traveled 2 kilometers. The force he applied is 500 Newton. Now we ask it to find work done. This shopping cart is traveled by 500 Newton in angle 30, 2 kilometers it traveled. So now we can find work done on this shopping cart. Work done is, now we should have to find, okay, horizontally, traveled horizontally. Okay, this cart can come around here. So from here to there we have 2 kilometers. Now we can find the work done. But as we have said before, work done to be found, force and distance should be in the same direction. Now we should have to find this component, the horizontal component of this force. So let us say this one x. We consider this one x, the horizontal component. X is equal with the, okay, from the relation let us start. Cos of 30 is equal with x over 500 Newton. Now x is equal with 500 Newton times cos of 30 degree. Cos of 30 degree is 0.87 approximately. So 500 times 0.87. We can have the value from here. So we can find work done here. Work done is now this is simply force times this minus cos of 30 degree. Also, we can say this one. So instead of x, we can use f cos of 30 degree times 2 kilometers. Now 500 Newton times cos of 30, 0.87 times 2 times 10 to the power of, this one is 10 to the power of 3. Kilo is 10 to the power of 3. meter. We should have to put our displacement in a meter. Meter is the SI unit of our distance. So finally we can have, when we compare this one, we can have around 870 kilojoule. This is the answer for our work done on this shopping cart. This shopping cart is traveled 2 kilometers by 500 Newton. Force is acting horizontally by in angle on this shopping cart. So finding work done on this shopping cart is by using this formula. This formula is work done is equal with force cos theta times the distance. Now, by using this equation, in this formula, we can find the value of work done or energy transferred into this shopping cart. In some extent, this problem is a little bit, it is complex, but if you try more, it is very simple. Okay, now let us give you cues that we will answer on comment section. On comment section of this video, you can answer. I will give you two cues. Cue number one, it says if you rotate your belt, student should have to try this question. It is easy. Do you if you rotate your belt, are you did work? Okay. Two is number two. Okay. Is there work done on a car? Moving with constant speed. Constant speed. Along a straight level road. I'll give you two these quizzes to try and answer it on the comment section of this video. Try to also we can define mechanical work. Mechanical work is energy transferred by a force through a distance, and we also have did some examples depending on the work done occasion, which is we derived from the idea of mechanical work or dynamic work, which says work done is the product of force and displacement. So by using the examples which we did before, you can try more on it. This lesson is not the end on a work. On the next lesson also, I will do some necessary examples and types of work by defining them and by having new and necessary examples on work until I will come back on that video. Thank you very much. Try to answer these two quizzes on the comment section of this video. Thank you.